Okay, this is lesson 5.2, graph systems. And in this lesson, we're going to take two equations that we want to make sure they're written in slope-intercept form, y equal mx plus b. And once they're in that form, we're going to graph each line. There'll be two of them. And we'll see how many solutions that line has, that system rather has. If there is one solution, we're going to name it. So starting with example 1, it says y equal negative 3x minus 5 and y equal 9x plus 7. So on that first equation, and I think I'm going to label it 1 just to say it's the first equation, m is negative 3 and b is negative 5. So I'm going to plot my starting point, negative 5, on the y-axis. It's right here, halfway between negative 4 and negative 6. And then I'm going to use my slope, negative 3, which I could write as negative 3 over 1, to plot additional points. So I'm going to go down 3, right 1, plot a point. That's the same thing as going the other direction. Up 3, left 1, plot a point. Up 3, left 1, plot a point. I can keep doing that. Up 3, left 1, plot a point. Up 3, left 1, plot a point. And I can do that one more time. Up 3, left 1, plot a point. And then I can just draw a line through those points. I went all the way through my coordinate plane. So we've graphed one equation. Now I want to graph the other equation. I'm going to call it equation 2. And I'll label that other one, equation 1, on my coordinate plane. So on this equation, the slope m is 9, which we could write as 9 over 1. And the y-intercept b is 7. So on the y-axis, we'll plot 7, which is actually the ordered pair 0, 7. And I can't go up 9 on this coordinate plane. So I'm going to do the opposite, which is negative 9 over negative 1. So I'm going to go down 9 from 7, which would arrive at negative 2, and left 1, which is here. And then I'll go down 9, which won't quite fit, but I could go ahead and go a little off my grid, which would be about here. So I draw my line through the points and see where do they cross. Well, my lines may have not been drawn perfectly, but they both had this point in common, and that was where x was negative 1 and y was negative 2. So the solution is negative 1, negative 2. That is the ordered pair where my two lines cross. Example 2. My first equation is already in slope-intercept form, so I'm going to identify the slope, which is negative 2, and I could write it as negative 2 over 1. And I'm going to identify the y-intercept, which is negative 5. And I'll go ahead and graph this. I'm going to call it my first equation. On the y-axis, I'm going to plot negative 5. And then I can go down to right 1, plot a point. Or that's the same thing as going the other direction, because I'll do the opposite of negative 2 is positive 2. The opposite of 1 is negative 1. So I'll go up 2, left 1, plot a point. Up 2, left 1, plot a point. Up 2, left 1. Up 2, left 1. Up 2, left 1. Up 2, left 1. And so I've got these points. I'm going to carefully draw a line as close to that as possible. And that was my first equation. And I'm using different colors, and I'm also labeling these. On your paper, you could just use different colors. You could use different colors, or you could just label them as equations 1 and 2. Now notice the second equation. It is not in slope-intercept form. So I'm going to get it in that form by boxing in my y term. Get rid of 6x by subtracting 6x from both sides of this equation, which actually ends up moving 6x to the other side and changing its sign. I get 3y equal negative 6x minus 15. I couldn't combine those. They're not like terms, so I just brought them down in the order of mx plus b. And then I'm going to divide both sides of this equation by 3. 3 divided by 3 is 1, and I get y on the left side. On the right side, negative 6x divided by 3 is negative 2x. And then negative 15 divided by 3 is negative 5. So we've got that m, the slope, is negative 2. I could write it as negative 2 over 1. And b, the y-intercept, is negative 5. So we start at the y-intercept, negative 5. And then we notice that this is actually the same equation. So when I go down to right 1, I'm including the same points. We can say that's the same as 2 over negative 1. So I go up 2 left 1, up 2 left 1, and I just keep on getting the same points. Now we could have predicted this without even graphing both of these, because we notice that both equations have the same slope and same y-intercept. They're actually identical equations. And so that means they have all points in common, so that it has infinitely many solutions. Okay. Now for our last example, example 3, we're going to graph this system. We need to have both of these equations written in slope-intercept form first. So I'm going to start with the first one. I want to get that y term by itself on the left side, so we're going to subtract x from both sides of this equation. Oops, we've got 4y equal negative x plus 8. And then we're going to get 4 by itself, so we'll divide both, y by itself. So we're going to divide both sides by 4. When we do that, we get y by itself on the left side, and negative 1x, I'd have an invisible 1 there, divided by 4 is just negative 1/4 x. And then 8 divided by 4 is just positive 2. So I can identify that the slope is negative 1/4 and the y-intercept is 2, and we'll plot these. We'll plot the y-intercept at 2, and then negative 1 over 4 means we're going to go down 1, right 4, and plot a point. It's the same thing as saying positive 1 over negative 4, which means from the y-intercept we go up 1, left 4, plot a point, and we'll draw a line through these points. And that was equation 1. Now for equation 2, I've kind of run low on my space here, so I'm going to just rewrite that problem down here. 3x plus 4y equals 0. And we're going to start by boxing our y term and getting rid of this 3x by subtracting 3x from both sides of this equation. It cancels on the left, and we end up with 4y equal negative 3x. I could say plus 0, but that's unnecessary because adding 0 doesn't change a number. And now I want to divide both sides by 4 in order to get y by itself. So y is by itself on the left side, and when I pull my fraction out in front of x, I've got negative 3/4 x. So I need to identify two things. The slope, which is negative 3/4, and the y-intercept, which we don't see any number after 0, but what must be added to it for us to not see that value? It must be 0. So that means that this second equation, I'm going to start on the y-intercept at 0, and then I'm going to go down 3, right 4, and plot a point. I could also do the opposite, which is positive 3 over negative 4. from the y-intercept, I can go up 3, left 4, and plot a point. And then I'm going to draw my line through these points. I do notice I have a point in common. And this is equation 2. And they have this point in common, where x is -4 and y is +3. So -4, +3, and we're finished with this problem.